Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of July 14th this time around. So last week we had a lot of moon interference, and we did, we talked about some interesting things anyway. We'll try to make this a few minutes shorter than our video was last week. But this week we start out with a pretty full moon that wanes away well as the week goes on. So on the evening of the 15th into the morning of the 16th, really the morning of the 16th, because this rises about midnight. So we're talking about midnight on the night of the 15th. The moon is about 2/3 full, and it sits right above Saturn and Neptune. And so we've been talking about Saturn and Neptune really close to each other all summer long here. And now the moon passes right above the top of them. So it's a great time to get your binoculars out. Check out Saturn, Neptune, and the moon right there together on the night of the 15th as we transition to the morning of the 16th. Next night, 17th a.m., the moon's down to about 55, 60% full, and it's right next to 4.3 magnitude Epsilon Piscium, star in Pisces. So now let's jump forward a little bit. On the morning of the 20th, we got about a 1/4 full moon, rises about 1:30 in the morning, and it sits about 5 degrees north of Uranus. So if you've been using Saturn to find Neptune, this is your opportunity to use the moon to find Uranus. So get the moon in your binoculars, get the moon right at the top of your field of view in the binoculars, and Uranus should be brighter than the stars that are around there, and it should be bluer or greener than the stars that are in the field of view. And see if you get a chance to check this out. So this week maybe you got a good opportunity to observe both Uranus and Neptune, not something that's easy to do unless you really go out and know what you're looking for most times. Then one night later, a week after we started, but early in the morning, the moon's all the way down to about 15% full, and it sits about 7 or 8 degrees from big bright Venus that's rising into the morning sky. So get out at 4 in the morning to check this out. Should be a pretty good view. So that's what we got with the moon and the planets in the morning sky largely. Now last week we talked about Aquila, the eagle here. Let's back up to Venus for just a second though. Venus is about 70% full itself right now. Venus, like the moon, goes through a full set of phases. So when Venus is on the same side of us as from the sun, on the same side of the sun as we are, it's in a new phase or a thin crescent phase. And when it's on the far side, it's a full phase or nearly full phase as it gets around the far side. And so what we know is that when it's in the crescent phase, the Venus, is got to be much larger. The image that it makes is much larger because it's much closer to us. And this was Galileo's evidence as he trained his telescope on Venus, and he saw that the thin crescent Venus was 6 times larger than the nearly full Venus. That was exactly the size ratio that would have been predicted by the work of Kepler. And he realized that the heliocentric model of the solar system was really a good one because of this evidence that was there. So it's about 70% full right now. Maybe in binoculars you can see that. Certainly in your telescope you can see that. It's filling out a little bit. So it's getting fuller. It's moving away from us, getting smaller and fuller as the days go on here. Now back to Aquila in the evening sky. Rises, not too long after dark. We looked at this last week. We talked about those stars. You can go back and look at that. We're going to use lambda, the tail of the kite, as the jumping off point. So if we drop about 4 degrees, remember fist at arm's length is about 10 degrees. We drop about 4 degrees west-southwest of lambda Aquilae, we get to M11, open star cluster. Open star clusters are these star clusters that live in the disk of our galaxy, and you usually see them as just glittering individual stars when you find them in a telescope or in a pair of binoculars in this case. This is a big, bright, rich star cluster. It is, in fact, my favorite open star cluster of all of them. We talk about it every year this time of year. Go out and see M11. There is not a better example of an open star cluster on the sky, I don't think. Beautiful in binoculars, beautiful in a telescope with a wide angle field of view, a 30 or 40 millimeter eyepiece. Is going to give you a nice big wide field of view. great in photographs. Got a chance to take pictures? There's a great object to take a picture of. But drop another 3.5 degrees south-southwest down to M26, so about the same distance, but tilt more to the south, and you come to another open star cluster. Again, you can see it as a fuzzy patch with your binoculars. It's a great star cluster and would be considered even better if it weren't so close to this just fantastic example of an open star cluster. So we've got two beautiful open star clusters. See if you can get photographs of them. See if you can see them in your binoculars or your small telescope. Again, really great examples. Now back up this direction 2 degrees. So we go back sort of 2 degrees to the east, and we come to NGC 6712. That'll be your challenge object for the week. NGC 6712 is a globular star cluster. Remember, globular open star clusters typically have 500 stars, 300 stars, 100 stars, 30 stars, maybe 5,000 stars, but that's the idea. They've got tens to thousands, a few thousand stars in them. And they live in the disk of our galaxy, so they can be pretty close to us, and then make big, bright, glittering examples of this. Globular star clusters, hundreds of thousands of stars in them, all densely packed together and far away from us toward the center of the galaxy. And in fact, NGC 6712 is out there far enough that it makes a pretty small example on the sky. It's a bright, tight knot that is interesting. Another great thing. Take pictures of all of these things this week. It's about 3 arc minutes across. So that's pretty small for a globular cluster. It's out there pretty far. It's 9th magnitude. For example, we have some really impressive globular star clusters in Scorpius lying nearby, and we talk about those most years at this time as well. M62, M80, and M4. M4 is a big sprawling example, a loose globular star cluster that's about as big as globular star clusters you're going to see, and loosely packed. And it's 20 arc minutes. This is about 6.5, 7 times bigger than NGC 6712 in the eyepiece. So that gives you a sense. M62 and M80 are both 2 or 2.5 times bigger than NGC 6712. And these are other great examples in Scorpius that we can talk about later. But that's just to give you an example of some of the globular star clusters that we think of as really, really visually impressive globular star clusters. So you get a sense of how small and tight this is. It's going to look like a bright knot when you go out there and look at it, but it's something to go see. It's kind of fun in this region of the sky. M11, M26, and NGC 6712 as we drop off the bottom of Aquila. We drop off the tail of the kite right there. So that's what we got for you this week. Should be a pretty good week. Other interesting things we could go out and find because the moon's fading away, but next week with the moon really waned away, we'll have a chance to go out and talk about more things that we can see in both the evening and the morning sky. As always, thanks for watching, everybody, and we hope you have a great week ahead.